So today we're going to finish up with the descriptive part of logistic regression, and next week we'll do inferential logistic regression. So we're right here, and I just want to remind you that there's this bonus survey posted that's due Friday night, and this bonus R problem. So and the homework for tonight is posted. And after today's lecture, you'll be able to do it pretty easily. So let's get going. And so here we are continuing with logistic regression and talking about the odds ratio in particular. That's what we talked about last time. So we're actually going to look at the odds ratio for a binary predictor variable. Now, our logistic regression y variable is always binary, 0 or 1. So now we're going to look at the very simple case where our x variable is also binary, 0 or 1. And it's super easy to understand the odds ratio in this context because there's only two sets of odds. If x is binary, let's say it's gender, then it's either 0 or 1. In our case, we're going to look at gender, and we're coding males as 0, females as 1. So the interpretation of the odds ratio is super easy. It just means the change. Remember what the odds ratio is. It's the change in odds for 1 unit increase in x. But if x is binary, like in this case gender, it means just the change in odds as you go from male to female. So it's just the difference in the odds between males and females. In our case of what we're looking at getting into med school. We're going to continue with our same example where our y variable is acceptance to med school. You either do or you do not get in. All right, so the 55 students in the med school data set that we looked at last time, in the previous example, were also classified as either male or female. So the question is gender related to whether you get into med school or not? Is there gender discrimination? So we can use a simple logistic regression model with a 0-1 binary predictor to answer that question. And we're going to continue coding gender as 0 for males and 1 for females. All right, now let's look. Our data program fit this regression equation, a linear equation, in the log odds. Remember, the log odds equation is linear. So what is it? We can look here, and the log of the predicted log of the odds for getting accepted or not. The odds of the log of getting accepted or not is equal to, we've got these coefficients here, like this is our intercept and this is our slope for just the one x variable that we have. And so what it gives us is this linear equation, negative 0.2231 plus 0.8109 times gender. Right? And that's what the gender's coded. G is equal to 0 for males and 1 for females. So now what's the odds equation? This is our log odds. We're talking, when we talk about the odds ratio, we're talking about the odds. So we just have to exponentiate both sides here, and we get the predicted odds of getting into med school is going to be E raised to 0.2231 plus what? 0.8109 times gender. I'll just put a G. I can put gender in. Okay, so now, so what are the odds of getting in for both males and females, and what are the probabilities? All right, so remember, gender for males is what? For males, G is equal to 0. And for females, I'll just remind ourselves here, G is going to be equal to 1. All right, so what's it going to be? We're just going to put the odds for males. You'll just put a 0 in there. So you get the odds for the males predicted is equal to what? It's equal to e to the negative 0.2231 plus 0, plus 0.8109 times 0. That's just 0. So that's what we have, right? And what is that? E to the negative 0.223 is equal to 0.8. 0.8. And what is it for females? Let's just do it for females. So we'll repeat this for females, and what do we get? So the odds for females is going to be what? E to the negative 0.2231 plus now you're going to have 0.8109 times, what are you going to put in for G? A 1, right? So it's the same thing as multiplying e to the, this one, e to the 0.2231 times. This is our multiplicative factor, e to the slope here, e to the 0.8109. That's our odds ratio there, and that's the change in odds as you go from males to females. And when I did this, I got 1.8. So, so that's the odds ratio there. The odds of getting into med school are what? What are the odds of, are e to the 0.8109, that's e to the slope, that's our odds ratio, times higher for females. What is that? What is e to, e to the 0.8109 is equal to, I have it right here, 2.25. So that's the odds ratio, okay? And it's a special case of our previous definition of the odds. It's really easy to interpret in this case because remember the odds ratio is the change in odds for a 1 unit increase in X. And we were dealing with quantitative variables like biological science score before. So we were saying for 1 more point on the BS score, that means that your odds go up by a multiplicative factor of e to the slope for biological science score. But here when you have a binary variable, you just have 1 unit increase means just changing from male to female. So you get the odds. Since females coded as 1, this right here is positive. So we see that your odds are greater for female. It's higher odds because we coded this as 1. If we coded males as 1, then this would just change to negative. And we would divide the odds. You know, the odds would be e to the minus, right? So we'd be dividing by 2.25 instead of multiplying by 2.5 as you went from 1 unit increase. All right. Oh, we didn't answer this one. What's the probability? We did the odds, but now we have to do this part, and let's do this one as a iClicker. So see if you can remember from last time how we switched from odds to probability. Okay, so did everybody get a chance to answer? Let's look at this and we'll stop it. And the answer is this one, C. Let's see if you got it. Great. Okay. Because why? Because probability is odds over 1 plus the odds. All right. So let's go back and fill that in. And let's go back to the document. All right. So the probability is equal to odds plus 1 over odds. So that's 0.8 over 1.8, which is equal to 44.44%. All right, that's our probability, and this was the odds. And it's just a coincidence that the denominator here matches this, that adding 1 to the odds here equals the odds for female. That's just a coincidence, so I don't think that's going to happen. If you went in the other direction, it wouldn't. Okay, so now we have that, and oops, let's do the probability for females too. So the probability for females is going to be 1.8 over 2.8, which is equal to 64.29. All right, so now, so the question is, well, let's look at the next page before we go on. And some of you are probably, especially those of you who've had Stat 100 before, or have looked at chi-square tests for independence, are saying, isn't this the same thing when you have two binary variables and you want to see whether they're related to each other or how they're related, whether they're independent or not? You can do a chi-square test for independence. So let's do the same problem using a chi-square test for independence. And we can ask, is gender independent of acceptance to med school? And we'll look at the output below. Now, notice how we get just about the same chi-square statistic. I didn't show you this before because we're going to be talking about this much more next, but we can look at this. Okay, so we get, let's read this. Notice how we get just about the same chi-square statistic. This is 2.183. What did we get before? 2.197. Here we have a p-value of 13.83, and here we have almost the same p-value, but it's not quite the same. Why is it not quite the same? They're not exactly the same because, as we talked about last time, logistic regression uses likelihood methods, and chi-square is, this test doesn't. So they come up with, this right here is a slightly adjusted chi-square. We're going to talk about that more when we do inference, but so uses likelihood methods, I said before, to see, we read page 181. Talks about it right there. But for now, let's just look at this here. And I want to show you how the odds you can get very, very, very simply as a count. And they'll agree with the odds that we got by doing this, all this here. Okay? They're going to agree with these. I'll show you. It's just super easy because compute the odds. Remember, the odds is just the probability of success over the probability of failure. So for females, if you look at females, out of the, so that 10 failed, they didn't get into, accepted to med school, and 18 succeeded. So the odds are just going to be 18 over 10, or 1.8, right? So you can see it, remember the odds are equal to probability of success, which is what here? 18 succeeded out of 28, that's the probability of success, over the probability of failure. That's 10 over 28 failed. Okay, those cancel out, and we get 18 over 10, which is just what we've been talking about, the number of successes divided by the number of failures, and that's our odds. So you can see that agrees. That's equal to 1.8. That's what we got before. We can do the same for the males. So what's the males going to be? The odds are just going to be super easy, 12 over 15. And that's where the 0.8 comes from. So now what's the odds ratio with binary variables? This is very simple. So the odds ratio is what? It's just the ratio of their odds. So it's 1.8 over 0.8, which is our 2.25. So how does it compare? It's the same to what we just did. So you're going to do a homework problem just very similar to this. So it's the same. It might look a little different because these are slopes that are fit, so they might get rounded. So I'll just say within rounding error. It's going to always be the same. All right, so that's pretty much, that's that. And, oops, sorry. So, can we move on? Sound good? All right. So now my question is this. Okay, I want to look at multiple logistic regression now. This is going to be very, and here I'm really curious about it because I'm thinking, well, I'll talk about that in a minute, why we'd be curious about it. But first, what is multiple logistic regression? Well, it's just going to be adding more x variables, more than one, just like we did before. So the process of going from a simple logistic regression to a multiple is just almost exactly what we did before with regular or ordinary regression. Now we're doing it with logistic regression. You're going to find it's extremely easy because it's pretty much identical. All right, so the coefficients in the multiple regression equation are generally different from the coefficients in the simple regression. When will they be the same? When would the coefficients be the same? Only when all the variables are what? When would they wouldn't change? Let's think about it. Here, what are we doing? Well, let's just go to an eye clicker and think about it while we do the eye clicker. This is a good point for doing this. So let's go to the eye clicker and let's think about it. The next one. All right. So this is exactly what we spent a lot of time talking about, like adding another, like looking at the simple regression and then looking at the combined multiple regression and the partial slopes. So let's just check this out. So we say the log odds of acceptance into medical school, if you just look at gender, it's positive here, right? So it says females have an advantage. And this is the slope, how much of the advantage they have. Now we look at biological science score separately. That's what we did the week before. And it says, which is no surprise, that biological science scores are correlated with acceptance to med school. That for each, this is the slope is saying, for each additional point on your score, people on the average, their log odds of getting in are 1.276 higher. All right? Now, what I'm wondering is, okay, so now I'm going to put it into a multiple. I want to have two predictors now, biological science score and gender predicting getting in. Why do I want to do that? Because when I see this advantage for females, my first thought was this. I thought females are going to be discriminated against. And my first thought is, okay, we're seeing this positive slope only because females probably do better on their test than males. And that's what, but once we control, if we put biological science score in as a covariate, in as another x variable, then we'd make that effect disappear. If they are higher, I mean, it's like the confounder here. I thought the biologicals, yeah, if they're doing much better in their biological science scores, well, that's of course why they're getting this advantage, right? So why don't we look at people who have the same biological science score and see what happens to this gender code, right? And it should go down if they're positively correlated, if my theory was correct. So remember, if they were not correlated at all, if the females and males did exactly the same on the biological science score, then that's not going to change when you put them both in, right? When they're completely uncorrelated, you can put both variables in, and they're both going to add their separate effects. But these, when you put two variables in, remember the partial slopes? Remember when they're correlated? Part of it, do you remember that, what we did before? Okay, so now answer this question. Okay, I'm going to stop it. Let's see what you answered. They're going to go down. Good. Most people got that because let's just go down here. Yes, they will go down because in the simple regression, they're combining the effects of both. And when you separate them out, if they're both going positive, they're only partial slopes, right? So, I mean, if they did, okay, you got it. So now, what happened? Let's look at our, well, we can look right here. Let's just go to the next one. Whoops. What did I do? Okay, so now we can start this one. Okay, so let's look at this one. So now on the page, this actually, when we put them together, look, the slopes went up. You can look at your notebook. They actually went up, not down. So what does that mean? That means when we compare males and females who have this exact same biological science score, the advantage for being a female goes even stronger. When we control, remember that's what it does. We're controlling for the other variable. So what this is saying is, right here, that when you look at two people who have the same biological science score, the female is going to have a stronger advantage. So what do you think's happening here? Why did the female get even bigger here? Because, can you see why? Just choose one of these. Okay. So we'll stop it. And yes, they have to be negatively correlated for that to happen. So that's right. Good. All right. That means they have to be negatively correlated. If they were uncorrelated, they wouldn't change at all. But what it's saying is that there's the females. Look, think of it this way. Let's say when we looked, we thought there was no gender discrimination because females and males got accepted at exactly the same rate, right? But what if the females are doing much worse on their biological science score? That means that there actually is this discrimination, but we're missing it. There is confounding, but it's being masked. There really is gender discrimination, but we're not seeing it. That happens just as often as having a correlation, right? And then when you control for something, it disappears. We don't, but people never think of it that way. So this is a very good example of that. It happens just as often, right? Where you don't think that there's any discrimination going around because you're comparing apples to apples. But when you separate them into groups and look at people who have the same biological science score, you see that there is more strongly favored, more strongly positive favoring for women. So I thought that's an interesting example of that and something to always look out for that people forget about. So let's go back to the document camera. All right. So, I mean, this is a small data set, and unfortunately, there hasn't been a lot of research on this. This is a real data set, and I wish there was more on this, but it's hard to get your hands on this kind of data. Okay, so the regression equation, let's look at it here, is what? So this is our, now we have two variables here. We have a B1 and a B2, and we can fill this in. We have negative 17 plus for gender, this, and here we have for biological science score. Okay, look at the equation. Who has the better chance of getting into med school, males or females, given the same biological science score? Females, because the slope's greater than 0. And females are gender is equal to 1 for females. All right, right there. All right, so what's the odds ratio for gender, and what does it mean? What's the odds ratio? So the odds ratio for the gender, put it down there, is going to be equal to e to the slope for gender, right? E to the slope for gender, which is e to the 2.015, which is equal to 7.5. So that's a lot bigger than the 2.25 we saw when we didn't control for biological science score. So what does this mean? It means what? That if you're comparing two people, a male and a female with the same exact biological science score, the female has a 7.5 times, her odds of getting in are 7.5 times higher than the male. That's what it means. So it means the odds of being accepted to medical school are what? 7.5 times higher, 7.5 times greater for females than they are for males. Now this is what it usually means, but we have to add, this is exactly what it meant in the simple regression. Until we add what? Comparing, if they have the same biological science score, right? Comparing apples to apples. We're breaking into homogeneous groups along the factors that we think are confounding things like this, like the biological science. So given, and this is what multiple regression does, given the same BS score. And this would be hard to do. This is a huge advantage of building a model like this over, you know, doing all these stratifications where it's much simpler and easier to see things this way. We did that. This is exactly the same thing that we did before with ordinary regression. There's no new ideas here, but it's really good to reinforce these ideas, to think about what happens to these slopes in the multiple regression model. Okay, so now what are the odds ratio? Okay, let's look at the other slope. This one. What's the odds ratio for biological science score mean? So the odds ratio for the biological science score is going to be e to its slope, which is equal to 5.26. All right? So it went up 2. Now what does it mean? Now we're controlling here for the other variable, gender. So it means if you look at two people with the same gender, 2 males or 2 females, the same, and compare their biological science scores, then for each additional point on their biological science score, their odds of getting in are multiplied by 5.26, by e to the slope. So if they're 2 points higher, it would be 5.26 times 5.26. Now you're comparing males to males and females to females. So let's write that. So the odds of being accepted, it's the same thing, the odds of being accepted, that looks like, that says, right, are 5.26 times higher, whoa, look what I did, so sorry. 5.26 times higher, you multiply by 5.26 for each additional point on the biological science score. What? I have to say given something, because I have to control for the other one. This is how it looks in simple regression. This is the meaning. But in multiple, you have to say given that all the other variables are the same. Any other variables are the same. You're keeping all those the same, and you're just seeing the effect of this one variable. That's why they're called partial slopes. Okay, for each given, you only have this other variable, in this case is gender, so given the same gender. Now I say higher, I mean, you just multiply by e to the slope. So if we had coded it the other way, or if it turns out females, yeah, if we'd coded it with males equal to 1, this would just be a negative here. So the odds ratio would just be 1 over 5.26, so you would divide by 5.26 instead of multiply. You're still multiplying by e to the, you'd still be multiplying by it, by e to the negative, you'd be multiplying by e to the negative 1.66. You're multiplying in either case, it's just, if it's negative, you're going to be multiplying by a number less than 1. That's all. Okay. I think you understand that. Boy, we don't really have much left to do. We're just going to interpret that, and then we're going to go home. Because I don't want to load too much on. It's because we did so much work earlier on multiple regression, and we did a lot of work introducing logistic regression. So we'll start inference next week, but let's just fill out this page, and this is just arithmetic. Just arithmetic. So what's the log odds? Okay, so here we have our log odds equation, and we want to fill out this table. Well, we can just plug the numbers in. That's what I did here. You can plug the next ones in, just so you can get used to it. So if you have a 10, if it's a female, that means you're going to put a 1 in here. 10, you put a 10 in there. And so we get negative 17 plus 1.66. I'm not going to do the whole table because this is just arithmetic. But you'll do it on your, you'll figure out shortcuts to do this. You'll use the odds ratio, etc. on your homework. After you do enough of them, it will be very simple to see. So this is times 10, right? And what do we have to add for a female? What do we have to add? Plus 2.015 times 1. So we're just going to make that be 2. So here's your additive factor. It's negative. This part's negative 0.4, and we're adding that. So we get 1.65. So now instead of e to the that, it will be e to the negative 0.5. Well, we can just do it. It will be e to the 1.65. and that's 5.207. Of course, that's the same thing as multiplying 0.67 times the odds ratio, right? And then for our probability, it's just going to be 5.207 divided by 6.207. You might have to leave all your decimal places in on the computer program. You might not want to do this rounding I'm doing here. Leave them all in because it's randomized and people are getting, we have to be very careful about that. So yeah, leave all your decimals in unless it tells you otherwise. Okay, so let's not forget the probability is odds over 1 plus the odds. Okay, I'm not going to fill in the rest for you. I can give you the answers and you can check them. Just to make sure you're doing it right. If you got this, if you end up with this, that means the rest of it's right. All right, now, so let's look at this. Now, a female has a biological science score, this is what we did before, 2 points lower than a male. How do the odds of the female getting into med school compare to the odds of the male getting in? All right, so now here, we're not given what her score is, so we're not going to be using that. So let's just remember our odds ratio. So the odds ratio, let's write them both down. The odds ratio for gender is equal to e to the 2.015. That's for gender. And the odds ratio for the biological science score is equal to e to the 1.66, right? And what were those? This was something like 5.26. And the last one was, the other one was 7.5. Okay, so these are what we're going to be using. All right, so a biological science, okay, a female has a biological science 2 points lower than the male. How do the odds of female getting in? All right, so let's just take it step by step. It's 2 points lower in the biological science. So for being female, first she's a female. So let's look at the female right here. So that's going to be e to the 2.015. So she gets this advantage for being female. And then, but her biological science, it's lower, so she gets this disadvantage. E to the, instead of, it's lower, so that's minus 1.66. That's for the first point lower. And then e to the minus 1.66 again. That's for the second point lower. I'm using this instead of these rounded answers because I don't want to accumulate rounding error. Okay, and so that's what I got. E to the negative 1.305, which is 0.27. So what does that mean? That her odds are e to the negative 1.307, which is approximately equal to 0, only about a quarter the odds of a male. So a male, those 2 points are worth more than being female. That's what it's saying. All right, she has a lower odds. Remember, they're equal odds if they're 1-to-1 odds. All right, the odds of a female, when are they the same? So it's going to be somewhere between 1 and 2, I think, right? Because the slope for gender is higher. So you know for this is higher than a 1 point increase in that. So it's got to be, and it's lower for 2 points. So it's going to be somewhere between 1 and 2, but where? So how would we figure that out? So let's think about it. So the odds of a female getting into med school are the same. We want them to be the same. So the odds, okay, so what are the odds of for the female getting into med? The log odds, the equation we have for females is negative 17. I'm just looking right up here. I'm putting a 1 in for female. Right? I'm just going to put a 1 in for female. So negative 17 plus 2.015. And there's the 1 for female, plus 1.66 times her biological science score, so that's hers is that. When is that going to equal? For a male, it's going to be exactly the same thing, except I'll put a 0 in here. When is it going to equal this? Negative 17 plus 2.015 times 0 plus 1.66 times what? The biological science score for the guy. All right? So I just want to look at the difference. I'm just solving for the difference of those two. That's all I'm doing. So when these two are equal, right? So now we can scratch those both off, right? This is just 0 here. So what do we wind up with? We can put these on the same side. So we'll end up with 2.015 equals what? We put that over here. 1.66 times the biological science score for the male minus the biological science score for the female, right? I'm just subtracting that from both sides. And now just divide. And that's the difference. So they'll be equal when, and that right there is equal to, this is equal to 1.214. So that is our answer, the difference between them. So how do we answer this question? That's when the male has a higher than the female. It says when the female has what lower, she has a 1.214 lower. So that's the idea there. And that was just the arithmetic here. And let's see, and then you're set to do your homework. And next time we're just going to look at inference and confidence intervals, and we're going to do significance tests. And we have a lot of time before the exam, which is Monday. So we'll have time for a review, for sure. Or a free class.